Very cool. Okay, not necessarily related to our class, although it's science, so sure. Just got a Washington Post alert that they are authorizing the new variant-specific COVID boosters, which is very cool. Extra cool for me because I've actually been a participant in the clinical trial for it. So I am a guinea pig. I actually was just at the research center yesterday, giving them a whole bunch of my blood. So that's pretty cool that that is happening. Okay, so today the more activity is much more chill, it's just a hypothetical. So take about 5 minutes, go ahead, and you don't even have to open this or write anything down. Just chat with someone near you. Again, like at least one person. If you want to do a group of 3 or 4, that's fine. And talk about if you had to design a research study to examine personality, what type of method would you use? How would you measure personality, do you think? And then once you had your findings, how would you present them to the world? So again, take about 5 minutes to do that. And then we will chat through some of the examples. Is everybody done, or is everybody just thinking? Just thinking, okay. I was like, maybe this doesn't take as long as I thought. I don't know. Again, these are like my musings at 8 a.m. I don't know why they keep coming to me, but we're gonna try them.
Yeah. Personalities, all the characteristics of situations and yeah, that's good.
Oh, the last one would be like, how would you get the word out if you found something really cool? Like, would you do a press release? Would you go to a conference? Would you make an interpretive dance? I don't know.
Do a TED Talk?
Yeah, TED Talks are a good example, I feel like.
Yeah, that's the one we're Unless you like how to get it. Yeah.
All right, now there's quiet. Is everybody good? Okay. Let me turn off my Fitbit timer here. Okay, so who wants to volunteer an example of how you would study personality? Bueller? Yeah.
Came up with the idea of observing them without them really knowing certain situations, because if you do like a questionnaire or you tell them you're gonna want someone to go on to see what have good traits in themselves and react to them. But if over the course of time you study them, regardless of ever like good day or bad day, you can see how their like traits and characteristics function.
Yeah, oh, that's really interesting. Yeah, I like that. Obviously, you'd have to be ethical about it and not be too
Yeah.
invasive, right? But yeah, I think of a few years back, someone did a 480, the psychology capstone for the BS study, where they had two people that I guess they determined and everyone was okay. Like one person who was considered conventionally attractive and the other person who was like more average go around, and their study was to see who would sign up for a psychology study. So they'd go around the grill.
Oh, I remember that one.
Did you? Yeah, and they would like try to see who would sign up, and I believe the more conventionally attractive person did get more people to sign up. So there are ways you could do it. I'm thinking of a bad example. We did not let this study happen. Several years ago when I was on the IRB, there was an IRB, Institutional Review Board, application to do an observational study where they would stage a fight in the grill and then just like see what happens. And we were like, no, someone's gonna get hurt because someone's gonna think it's an actual fight and jump in the middle, right? So yeah, you could do it in lots of good ethical ways. Cool. And how would you present your findings to the world? Yeah, this is the hard one, right? Like, how do you get it out there once you have this cool stuff? Yeah, so it could be you're going to give a presentation at a conference. It could be you're going to write up a journal article so other scientists can see it. It could be you try to put out a press release, do interviews with the media, like lots of different things you can do here. All right, let's do one or two more examples. Yeah.
We were talking like the social experiment, kind of like the Samaritan study. Like similar or something, like, you know, like who would stop for someone who's broken down on the highway.
Oh,
or something
nice.
like that. And then we would measure personality through like traits, so like how they would act towards that person. And then we thought of like a TED Talk to present.
Yeah. So that's like a really nice example of, especially once you're established, ways that you can get it out there. And like not only now are TED Talks good for, you know, the audience who will be there, but they stick them all on YouTube, right? So people can watch them for generations to come, and professors use them in class sometimes. Those of you who've been in my classes have seen snippets of our whole TED Talks before. All right, one more example. All right, everybody's just not feeling it today. Respect. On Friday, we are having our first discussion day, so do come ready to talk about the extra readings. So there's 2 readings, I believe, in the Pieces book. And if you are still waiting for your Pieces book to come in, I did scan those, and those are posted on Blackboard. Here, I could actually show y'all right here. So if you go to Blackboard readings, it does include those 2 readings. And then there are also 2 readings about sort of critiquing how we tell the history of psychology, which I think is really important. And then we'll have an in-class assignment. All those small like assignment ones, they're always going to be in-class group assignments. So you all will work through those questions together and then we'll report out. So hopefully y'all will get more comfortable doing that throughout the semester and warm you up for our simulation at the end of the term. Yes. Yep. Read all of them. And, you know, skimming is okay. And just come ready to discuss them.
What chapters?
So that's a good question. So in the Pieces book, what I have done is I will on the syllabus, or here you'll see, here, let me pull up the syllabus real quick. So scroll down here. So you read the readings by these authors. So in the Pieces book, there'll be a reading by McAdams, and there's one by Vasery and Neal, and they're both near the beginning, and you read those 2. And then there are the additional Blackboard. And the reason I don't have the authors for the Blackboard one is A, so you don't get confused, the dig through the pieces book, and B, because sometimes I change those up depending on the semester. So it makes it easier for continuity for me. But yeah, so again, if you're still waiting for your pieces book, the first couple are scanned here. You even get my highlights and notes. I'm also a horrible scanner, so apologies that some of the pages look like this. I'm just really bad at it. But then you also have other PDFs that are primary source articles as well. So that is for Friday. So come on in ready to discuss. So that makes it more of like a relaxed day than me talking at y'all. All right, any other questions about logistics of course materials or anything? We're making it through the first week. We're doing great. And we're gonna jump on back in to our lecture on research methods here. No, I'm not trying to share. That's my bad. Slideshow. I discovered during the pandemic, and so I should know by now that I cannot click and talk at the same time. So I just need to know that. Okay. So we were starting to talk about extensions of the correlational method when we ended on Monday. So we talked about epidemiology. So we typically think of this of actual medical diseases, but we can look at this for things like depression or the rate of death by suicide or PTSD, for example. There was a lot of research about the incidence and prevalence of PTSD following 9/11. And so as I was referencing at the very end of class, this shows I believe it's prevalence. Let me double check in my notes. Yes, the prevalence of depression among different age groups. And so, and with gender. So women are red, men are blue. And here you can see it really spikes, unfortunately, for college women. But we know that this data is a little older. If you did this, I should look for a new one actually. We now know that levels of depression are actually fairly high among the elderly as well. Longitudinal studies are sometimes really considered the gold standard in psychology. So this is, you take the same participants on many different occasions over a period of time. And so you might start when kids are 4, and then maybe every year or every 2 years, you're getting back in touch with those kids and their parents and following them over time. Now, if this is the gold standard, why do y'all think there would be so few of these? These are really few and far between. Yeah.
It takes such a long time.
Takes such a long time. And the sad thing about our science is that sometimes it's partially determined by the circumstances of the researcher. If you're an early career researcher, if you're someone who just got your PhD, is sort of trying to establish yourself in the field, maybe you're at an academic setting and you're trying to get tenure, you have to publish a lot. And if you're waiting for the results of these studies, it might take too long, right? Yeah, what's another reason why people might not do this as often? Give it. These are really expensive to have the person power to follow these people up. Often you're paying participants each time to participate, right? So unless you're getting giant grants to do this, which people in psychology can do, people in psychology get multi-million-dollar grants, but these are going to be really difficult to do. So in psychology, we tend to see more one-off studies, or we'll see a lot of treatment studies where they might do sort of pre and post treatment and then follow them up at 6 months and a year. Structural equation modeling is a way to look at essentially correlation of a whole bunch of different variables at once. And so you're taking potential causality or directionality of relationships into account, while also accounting for all the other potential variables that could be related, at least in sort of your mind based on existing theory. So this is an example from my own master's thesis. There we go. So I was looking at social pressures from moms, dads, siblings, and peers. I was looking at media pressures. And then I was looking at internalization of the thin ideal. This is the idea that you see, I was looking with women in particular, but we see this in men too. You see this idealized image over and over and over and over and over, to the point that you sort of are like, well, that's what I'm supposed to look like, right? And if I don't look like that, then that's a problem. And we know that that's linked to body dissatisfaction, probably not surprisingly, right? If you don't fit this ideal, you're going to be unhappy with your body. And then there's another factor that I mentioned before, self-objectification. This is the idea that you've internalized that thin ideal so much that you start to see yourself more as an object than as like a fully functioning person with emotions and agency, right? And it's more about, I'm just going to focus on my body. So I included all of these factors, taking everything into account. And what you can see is that some of these relationships are pretty strong. This is based on the same correlation matrix we talked about on Monday, where 0 means no correlation. The bigger it is, the stronger it is. Usually in psychology, we want to look for something sort of in the 0.5, 0.6 for a strong correlation. If you get too much stronger than that, if your correlation's at like 0.8, 0.9, you're probably actually measuring the same thing, right? Instead of two different variables. This is a fancy term called multicollinearity. Y'all do not have to know that term. I learned it in graduate stats, right? But it's something we take into account. But here you can see 0.56, 0.56. Some of these are pretty strong. Interestingly, the social pressures didn't predict, and that may have been a function of the measure I use. So sometimes if we use a not well-validated measure to try to get at something, we can miss some of that. Or it could just be at this point in, it was like the early 2000s, the aughts, right? That social pressures for college students just weren't as important as media pressures. So this is SEM, and it lets you look at everything all at once. All right, and then we have correlational studies having advantages and disadvantages. As I said, all of these, there are good things about them and there are not so great things about them. So the advantage is that this is often very cost effective if you're not very longitudinal research, especially in this day and age. You can often throw this on like a Google form, send it out in an email, post it on social media, get a whole bunch of people to fill it out, right? And back in the day, we would just like, the only cost would be photocopying, right? Now you might have to pay a small fee to a more sophisticated survey service to use it. It's also very efficient. A lot of times when we do experiments, which we'll talk about next, we only have one person in the lab at a time. If I was doing a correlational study, I could hand it out to everybody in here at the same time and get data from all 16 of you instead of one at a time. So as a result, it's much easier to get a larger sample size than when you're doing those in-depth case studies or experimental studies. So, I mean, granted, this was at a large public university, but when I did that study, I just showed you the diagram for, I got data from 250 people in about a month and a half. And that was when people were like actually still coming in person. Bless you. Disadvantages. As we mentioned, you can't determine causality from this. So even if I find the best correlation in the world, if I'm looking at this, I still can't say that thin ideal internalization causes body dissatisfaction, right? I can only say there's a relationship between the two. Another disadvantage is generalizability. They're so easy to run that they're often performed with folks like yourself, college students. We call this a convenience sample because it's just sort of like who's ever around and convenient, right? So then we end up with problems with age limitations, right? We end up with most of our samples looking at people 18 to 24. Socioeconomic status, folks who are not can't afford to go to college. And then, as I think I've mentioned previously, Wesleyan isn't bad with this, but we can end up with problems with ethnicity and racial representation. Wesleyan's about 40% students of color, which is awesome. Where I went to undergrad, it was like 7%. And even when I was at this large public university, when I collected that data, I believe I had like 10% racial, like everybody else was white. So if everyone is using those samples, we're missing the stories of a lot of people, and we might be missing how personality traits come about in non-college, non-young adult, right, non-white people. Another problem here is dependence on retrospective recall, which means these questionnaires require you to answer some things that have happened in the past. So depending on the questionnaire, a lot of times the directions will be like in the past month or in the past 2 weeks. I don't know about y'all, but if I think about last week, I don't know if I could tell you what I had for breakfast on any given day, much less like how I was feeling depression-wise, right? So like people aren't necessarily the best reporters of this, even if they're trying, earnestly. We also have to worry about, which I think some of you mentioned, the idea of how people might present themselves. So they're trying to present the good traits or what they think we as researchers want. And so sometimes what we'll do in studies is include a measure of social desirability. So sort of how much they want to look good to other people, and then take that into account in our analyses. All right, the experimental method. So this is sometimes considered the gold standard, although more and more it really is working different methodologies to ask the same question. But this allows for determination of a causal relationship between two variables. Caveat, within a very controlled setting, right? And we'll get to that. So an experiment involves random assignment. So that means anyone who walks in to do the experiment has an equally likely chance of being in one group versus the other. And they have manipulation of a variable called the independent variable. So this is the variable you believe is causal. So we go back to what I was talking about on Monday. If we want to study depression and stress, and we want to induce a feeling like depression in people, right? Our variable might be listening to sad music versus listening to upbeat music, right? And then the dependent variable is what you measure. It's what you assume is controlled by or affected by that independent variable. So in the case of we're manipulating the feelings of depression, we might then measure stress and see how stressed out people get when we get them sad. And again, ethically, we would always undo it at the end, both through debriefing, but also sometimes like playing some upbeat music or things along those lines. One of the biggest things that researchers who do experiments try to really focus on is eliminating as many, ideally all, of the confounds or what are sometimes called nuisance variables. And these are variables other than the IV that can affect the dependent variable. These can skew results and make it look like we have a finding when we don't, or hide that there are differences when they're, it looks like they're not. So there's a couple things we do to guard against that. One is that random assignment to the control versus experimental group. So the control group is a group of participants who are not exposed to the IV, or they're exposed to like some different version of it. So again, in the case of this depression and stress hypothetical study, they might be exposed to neutral music or upbeat music rather than the sad music. Or sometimes the control group just wouldn't get any music at all. Other than not being exposed to the IV, their experience is similar to that of the experimental group. So they go through all the other same steps. Everything else would be identical. By comparing the outcome then of the control group and the experimental group, researchers can better determine the effects of the independent variable. So this allows us to say, yes, it is feeling depressed that's causing people to also feel more stressed. Random assignment assures that every participant who comes in for that experiment is just as likely to be placed into either the control or experimental group. And back in the day, we would actually flip a coin. I think some people still do this, or we'd have like a jar or a hat so that they pull out a paper that says which group they're in. Now, a lot of times we use a random number generator. So the one I prefer is called random.org, and it allows you to put in, I have 10 people coming in today, and I need each of them to either be randomly assigned a 1 or a 2. And you assign people that way. And then we can also do what's called a blind design. And so this is built around, this would be for application treatment studies. And this is built around the idea of placebo therapy, which is the idea that you can substitute an imitation, something that looks or tastes like real therapy, but is not. And why we do this is we're designed to get rid of experimenter bias. The best meaning, purist researchers can sometimes still unintentionally convey their hypothesis to people. So you might say something like, let's take it, we're doing not even therapy, but pills, right? People coming in trying a new pill. Take this pill, it'll really help with your depression. Or just take this pill, it'll really help with your depression, right? I said the exact same thing, just in totally different ways. So the way we try to eliminate that unintentional bias, which is also called the Rosenthal effect, which is where we unintentionally transmit our expectations, is we do these blind designs. So a single blind design would be the participant themselves doesn't know if they're getting the real treatment or not. So they're getting the sugar pill or they're getting sort of the placebo therapy. The double blind design is neither the participant nor the researcher with them knows. So there would be a principal investigator, the researcher in charge, who would have a master list somewhere, but the researcher who's in the room with the person doesn't know if they're handing them a placebo or an actual medicine, or doesn't know if the therapy they're trained in is the one that they're trying to show works better. In a triple blind design, you would have someone else watching. So whether that's like through one of the one-way mirrors, or you would record it and go back later, and then they're going to indicate behavioral observations. So for example, you might do this with a medication for kids with ADHD, right? And it's pretty easy to see with kids with ADHD, like, are they on the placebo or not, right? Are their behaviors controlled or not? Actually, one of my grad professors told us a story about he worked on an ADHD study while he was a grad student. And he said the kids would come in and just be like, today's a placebo day, right? So even blind studies don't always work well if the effects are really obvious. So real quick, I do have a video about the placebo effect. So let me go ahead and pull that up. It's not too.
In 1996, 56 volunteers took part in a study to test a new painkiller called Trivaricane. On each subject, one index finger was covered in the new painkiller, while the other remained untouched. Then, both were squeezed in painful clamps. The subjects reported that the treated finger hurt less than the untreated one. This shouldn't be surprising, except Trivaricane wasn't actually a painkiller. just a fake concoction with no pain-easing properties at all. What made the students so sure this dummy drug had worked? The answer lies in the placebo effect, an unexplained phenomenon wherein drugs, treatments, and therapies that aren't supposed to have an effect and are often fake miraculously make people feel better. Doctors have used the term placebo since the 1700s, when they realized the power of fake drugs to improve people's symptoms. These were administered when proper drugs weren't available, or if someone imagined they were ill. In fact, the word placebo means "I shall please" in Latin, hinting at a history of placating troubled patients. Placebos had to mimic the real treatments in order to be convincing, so they took the form of sugar pills, water-filled injections, and even sham surgeries. Soon, doctors realized that duping people in this way had another use: in clinical trials. By the 1950s, researchers were using placebos as a standard tool to test new treatments. To evaluate a new drug, for instance, half the patients in a trial might receive the real pill. The other half would get a placebo that looked the same. Since patients wouldn't know whether they'd received the real thing or a dud, the results wouldn't be biased, researchers believed. Then, if the new drug showed a significant benefit compared to the placebo, it was proved effective. Nowadays, it's less common to use placebos this way because of ethical concerns. If it's possible to compare a new drug against an older version or another existing drug, that's preferable to simply giving someone no treatment at all, especially if they have a serious ailment. In these cases, placebos are often used as a control to fine-tune the trial so that the effects of the new versus the old or alternative drug can be precisely compared. But of course, we know that placebos exert their own influence too. Thanks to the placebo effect, patients have experienced relief from a range of ailments, including heart problems, asthma, and severe pain, even though all they'd received was a fake drug or sham surgery. We're still trying to understand how. Some believe that instead of being real, the placebo effect is merely confused with other factors, like patients trying to please doctors by falsely reporting improvements. On the other hand, researchers think that if a person believes a fake treatment is real, their expectations of recovery actually do trigger physiological factors that improve their symptoms. Placebos seem to be capable of causing measurable change in blood pressure, heart rate, and the release of pain-reducing chemicals like endorphins. That explains why subjects in pain studies often say placebos ease their discomfort. Placebos may even reduce levels of stress hormones like adrenaline, which can slow the harmful effects of an ailment. So shouldn't we celebrate the placebo's bizarre benefits? Not necessarily. If somebody believes a fake treatment has cured them, they may miss out on drugs or therapies that are proven to work.
So that kind of just talks about it a little more, and we'll talk about this in a few slides, but one of the problems becomes, what's a placebo for therapy, right? So, one of the things that we've traditionally done with therapeutic treatments is we'll do what we call a wait list control, where we'll just tell people you're going to get the treatment, but in 6 weeks. And studies have shown that just being told, kind of like they were just talking about the placebo effect, just being told you're going to get some help can actually make people start to feel better. So then we're seeing, does the actual therapy help people improve over and above just hoping they'll get help, right? There are many extensions of the experimental method. One of these is the quasi-experiments. This is where you cannot randomly assign people to groups. So you couldn't ethically cause someone to develop a phobia or experience child abuse. So you would compare these individuals with matched controls who didn't have those things or those experiences. Natural experiments occur when nature itself or a larger man-made phenomenon manipulates the independent variable. So natural experiments may examine the effects of such events as hurricanes or terrorist attacks. So again, I know that for y'all, like 9/11 isn't quite as prescient as it is for folks from my generation. I was in college when 9/11 happened, so it's very seared in my brain. I have what's called a flashbulb memory related to it, and then I can remember where I was when I found out. I can remember a lot of what happened that day. Although there's really interesting research about how inaccurate flashbulb memories are. So I kind of like, how much of that is true? I don't know. But this was a huge event for the US. So in the wake of September 11th, they did a lot of studies looking at the effects of those experiencing attacks, or those who had loved ones who were victims of the attack or who witnessed the attack. And studies have examined predictors of developing PTSD, the effectiveness of therapy for those affected with the attacks, and even considerations such as whether or not, well, actually just looking at why there was a higher incidence of alcoholism among the Red Cross workers who helped after the attacks. So we would never want to cause a 9/11, right? For those of you who have seen Unbreakable by M. Night Shyamalan, we don't want to be Mr. Glass. We don't want to be the person causing these things to study them. But when they happen, we do try to benefit from, see what we can help. So for example, based on this research on 9/11, I have a friend from grad school who actually not really deployed because he's not in the military, but was sent to Japan when they had the tsunami that affected their nuclear power plant, and used techniques that were developed following 9/11 to help people in the immediate aftermath, right? So it's not about exploiting, it's about trying to find out what helps people in the moment and how can we apply that in the future. And then analog experiments involve using animals in the lab to examine these things. This is harder in personality, but there are some things we can observe. Like for example, we can actually study things like superstitious behavior in animals. And then this is really controversial, right? I mean, a lot of psychological studies just sort of look at how animals react to reinforcers. But a lot of modern psychological animal studies will actually include things like having probes in the animal's brain while it does things to see what lights up. And so this is controversial. It's not something I've ever engaged in myself, but sorry, random story that made me think of. So we did have folks who worked with animals in the experimental program of my grad school. And one time we got a email that said, if you see a rat, we don't have an infestation, one got away. And all the clinical people were like, go little rat, go. Because unfortunately, a lot of times after the experiment cycle is done, these animals are just euthanized. So again, very controversial. Our friends, at PETA down in Norfolk might have things to say. But there are certainly ways you can do this more or less ethically. And certainly things like studying behavior is very different than, Johnson & Johnson dropping eye makeup into rabbits, right? All right, so again, like anything else, there are advantages and disadvantages. With the advantages, again, you have the ability to control that environment much more so. So as a result, you can come much closer to determining that causality among the variables. And again, it's easier to get large sample sizes here than, let's say, case studies, although certainly not as large as correlational studies, depending. The really interesting thing, though, is that now we can do a lot of experiments online, where you would be filling out a Survey Monkey and you'd be randomly assigned to a group based on some sort of algorithm formula within the survey, and then maybe you watch a video or do an activity. And so this has opened up to larger samples in kind of the same way correlational studies can do. There are some disadvantages. It is tempting to say you have absolutely determined causality because you did an experiment, and experiments let you say causality, right? But there are variables you don't anticipate or control that can still make a difference. In addition, it's not always clear whether what's occurring in the experiment is what you expect to occur. So an example, a lot of the research done on body image, you show pictures of the thin ideal. to people. And then you measure their body dissatisfaction before and after. And the assumption being made is that when we look at pictures like that, we are comparing our bodies to that person. But we don't know that that's actually happening, right? Someone might just look at the image and be like, okay, that's a person, whatever, right? And so really interestingly, when I was in graduate school, I did a meta-analysis, which is where you take existing studies, and each existing study now becomes like a participant, a single data point in a larger study. And I looked at this compared to studies that had actually measured social comparison. And probably not surprisingly, the ones that actually measure social comparison found a stronger relationship than the ones that just sort of assumed it was happening. So we have to be careful about things like that. In addition, experiments by nature create artificial scenarios or environments. So what they measure may not be the same as what would occur in the real world. Experiments also sometimes require deception, which people have ethical concerns about. And some experiments just can't be performed. Again, we can't randomly assign someone to be abused or to be a certain ethnicity, right? You can also do a single subject or single case experiment, which is basically an experiment and a case study squished together. So these are case studies that have been used to develop and test therapy techniques within a scientific framework. So here you do an experiment, but on the same individual over time, and their behavior is compared at various time points after an intervention is introduced. And the most common example here is the ABAB design. The first A is before you do anything, just baseline when that person comes in. The first B is when you first introduce that therapeutic technique, your independent variable. So we see, does their behavior change after the IV was introduced? So if it does, that's great. But because we only have one person, we can't really say, yes, for sure, this is what changed. Because they could have something change in their home environment, right, or at school, something along those lines. So then what we do is we remove the IV. We take away whatever treatment it was, and we see, does it go back to baseline? And then if we see that, we reintroduce that treatment, that IV, and we keep it there to help the person. And so this is a really cool case example of this. This is a case called Chris. So she was a 19-year-old woman who had developmental delay. So if you don't know what that means, it essentially means she wasn't operating mentally at the 19-year-old level, right? So she might have been more like a 10-year-old. And she also had a disorder called trichotillomania. Again, not something y'all need to memorize. But this is a disorder where it's an impulse control disorder, often linked to stress or anxiety, where people will just pull their hair out. And sometimes they don't even realize they're doing it. And it could be hair from anywhere on the body. So I had a student with this once, and I could actually tell when she was really stressed out because like half her eyebrow would be gone. That's where she plucked from. So this certainly can happen. And so here it's interesting because we have a much longer baseline. And you can see they were probably trying a whole bunch of different things to try to help Chris, right? The problem with applying traditional therapy to someone like Chris is that the traditional therapies are developed for a pretty high intelligence level. They're cognitive in nature. You do a lot of talking about what's going on. And for someone who has this developmental delay, they're just not going to work. And so the therapists were just racking their brains, trying to figure out what might work. And what they did is they took some wrist weights, 2.5 pound wrist weights, nothing too heavy, but just enough that when she moved her arm, she would notice. And so they did this, they would videotape her while she watched TV to see how much time she spent manipulating her hair, pulling her hair out, because that's when she tended to do it. And so what they find is when they did that, she stopped doing it altogether. Well, there were a couple other times that it seemed like they had gotten rid of it, but it came back right here. So then they took off the weights and recorded her sitting in front of the TV, and it went back up to about sort of her average. Then they put the weights back on. Boom. So something as simple as that. And, you know, ideally she wouldn't need to wear the weights for the rest of her life. She would like get that awareness and be able to stop herself, right? But simple little intervention, not something we could do in a large sample of people, right? But worked for this one person. All right, so one of the things that Funder talks about quite a bit in your book is representative design. So Funder says that not only should we try to like get representative samples with a lot of different people, but that we want to do different types of research methods to ask the same question and try to answer the same question. So each different type of research methods only give a snapshot or a little piece of what's going on. So Brunswick, way back in the 50s, recognizing this, suggested that in addition to sampling participants, we should also include different types of domains. So like if we're doing college students, we should draw randomly from all students, not just like the folks in psychology classes who are convenience samples. Different possible methods, so do a correlational study and an experimental study. The different types of performances, so several different ways of inducing a variable. So if I'm trying to look at depression, right? Maybe one study I induce it with a song, another study I induce it with a video clip, another study I induce it by having them read a passage, right? And there are, of course, major challenges to do this, right? So if sort of one lab of researchers, one research group tried to do this for everything, you get back to the same problems we have with the longitudinal study, where it's time consuming, it's really expensive, it holds you back in terms of publications. But what Funder says that helps us fix this is that we just need to look at the body of work. Different studies by different labs, different research groups over time. And then, as I mentioned, a way of quantitatively combining this information is a technique called meta-analysis, where each study becomes its own data point or participant, essentially. And by combining these multiple studies and comparing over different studies, then we're able to see trends over time and across these multiple methods of research. So once we run these studies, how do we determine if the results actually are meaningful, right? So we do testing with statistics. And I wore my statistics chart stress for y'all today. I used to dance. Everything's a costume, I think, still. And the overarching term that's for the commonly used method is null hypothesis significance testing, which basically says, what are the chances I would have found this result if nothing was going on, if this relationship didn't exist? The most common statistic you'll see reported in the literature for significance is P level, which stands for probability level. And this gives the probability of getting a difference of that magnitude if the actual size was 0. So it basically says, if I found this on accident, right, how likely is it that there's not actually a relationship here? There are some problems with this way of looking at things. One is that it can be difficult to describe results. So this gives the probability that the results would be found if the null hypothesis were true. But, right, that's very wordy and hard for folks to understand. In addition, we tend to use P is less than 0.05, which essentially means there's a 95% chance this didn't happen on accident. And it's kind of arbitrary, right? Like someone just decided we were using that. Why isn't it 0.01 or 0.10 or 0.06, right? Another problem that comes out is type 1 and type 2 error. So p-value only looks at type 1 error. And so what this means is that you say two variables are related when they're not actually related to each other. So you found this on accident. So this would be if we're talking campus life, spreading a rumor that two people are dating who are not actually dating. So p-value misses type 2 error, which means saying one variable is not in a relationship with the other variable when they are actually related. So assuming two people are not dating, so you might hit on that person that you're attracted to. And then you find out he's dating a good friend of yours, and then later she sets you up and you get married. I don't know. That might have happened in my life. I don't know. So I didn't break the friend code because she set us up. I should have broke up. But we will stop there for today. We have just a couple slides to finish before our assignment on Friday. So thank you all for participating and see y'all then. Yeah, we're doing it in class. Yep. Yeah, all the like assignments will be group activities in class for this class.